probably going to be jumping around back and forth a little bit. So, Integrated 2, Chapter 5, we're going to continue with parabolas, and what we're really looking at in Chapter 5 is what can we get from the standard form. We know that if we factor using initial factoring or the diamond, that we can get it into factored form and that we can find the x-intercept. We already talked a little bit about that A opening up or being normal or whatever, but we haven't got into it very much. So what happens if it's in standard form? Well, we can find the y-intercept and we can find something that's known as the axis of symmetry. So we're going to talk about both of those things in standard form and just give us a more complete picture of what a parabola looks like. And again, we will learn how to complete the square and put it in graphing form in Chapter 9, but that's something that we're going to come up to later. Now, if we look at these Chapter 5 notes, I want you to see these first 5 steps are the same. This is what we did in Chapter 4, and these are all for when it is in factored form. Steps 6, 7, and 8 we can actually use when we're in standard form. So actually, I don't know, if I had done the book, I might have put these ones first and these ones second, but I guess it doesn't really matter. Long story short is we're going to do steps 6, 7, and 8 in this chapter. And it's going to be real similar to what we did in Chapter 4, where we just kind of work on it over and over and hopefully get the hang of it and look at just some different examples of it. We're going to talk about x-intercepts, which we already did. Just so you know, there's 3 other names for them: solutions, roots, or zeros. So if I talk about zeros, I'm talking about x-intercepts. If I talk about roots, I'm talking about x-intercepts. And if I talk about solutions, I'm talking about x-intercepts. They all have the same name. It'd be like someone named Robert or Bob. We're talking about the same person. They just have different ways of saying that person's name. Perfect square equations. It's a shortcut, really. You really don't even have to fill out anything here, but it might be good when we get there. It's like a shortcut way to solve some. Completing the square, again, if I refer back to here, there's 2 ways you can complete the square. One way is to get the x-intercepts, but as teachers on staff, we've kind of decided that we were going to ignore completing the square to solve for the x-intercepts, and instead we save completing the square to get the stuff that we're going to learn in Chapter 9. So when I do that, I know I've already made those videos. I made these videos out of order because of coronavirus, but I think when you get to the Chapter 9 videos, you'll see that I talk about just real quickly how to use completing the square to get the x-intercept. If I don't, and it's something you're interested in, you can definitely let me know and I will explain it to you. And then the quadratic formula we're going to use later in this chapter, so this will come up, but it will be in a while. And then we have the imaginary numbers and the complex numbers again. All 3 of these will come up in Chapter 5 Part 2, not Chapter 5 Part 1. We're really going to hammer Part 1 for a while here, for a couple days. Also, you'll notice this looks real similar to what you saw here. The steps 1 through 5 are the exact same of this worksheet, and I just added on a step 6, 7, and 8. So one thing we're going to do is we're going to find the y-intercept of an equation. So you'll notice here, I hope this makes sense, right? Like, I know when we talked about the x-intercepts, actually I guess I need to open this and write this, so I'll set this up. But when we talked about the x-intercept, actually I better do that. I'm wanting to write right on now. So we talked about that when we have x-intercepts, that we know that we don't know what the x is, but we know that the y is 0. Well, it's the same thing with the y-intercept, right? In this case, we know that the x is 0, but we don't know what the y is. So what we can do is super easy. We can just go in and say, all right, we'll make the x's 0. Plug in a 0 for this x and plug in a 0 for this x. And I hope you can see how easy this is. If I plug a 0 in, this turns into 0, this turns into 0, and all I'm left with is the 8. So I can pretty much tell that my y-intercept is 0, 8 just by looking at it here. Hopefully you see what I was talking about. If you do, you know that my y-intercept is 0, negative 10. Because if I plug a 0 into that equation, I'm going to get what's left over. So pretty simple step 6. Step 6 is very easy. Step 7, we want to get the axis of symmetry. If you think about it again, symmetry, it means it looks the same on one side as it does on the other. So there's this line that goes right down, an imaginary line that goes right down the middle of a parabola. This is known as the axis of symmetry, and this is important because the x-axis is just as far away from one as the axis of symmetry as it is from the other. So we'll talk about that axis of symmetry and how we can derive that, kind of the middle. And then we said the vertex. The vertex is either going to be the highest or lowest point of a parabola. So again, it's the highest or the lowest. Both of these points would be the vertex. Here's the highest point of a parabola. Here's the lowest point of a parabola. So what I want to do is I'm going to just grab a sample. We're going to go through steps 1 through 5 just like we did in chapter 4. And then we'll introduce step 6, step 7, and step 8. And then we'll just sort of go through the process again and again and see what we come up with. Old hat at this, we should be experts. So first thing I'm going to do is I'm going to factor out a 2. Ugh. Why is life so hard? Alright. The second thing I'm going to do is I'm going to set up my diamond. I'm going to get A times C. I'm going to get B on bottom. I'll put A on the side. I'll see what numbers work. So 1 and 4, it looks like will work if the 4 is negative. 1 times negative 4 is negative 4. 1 minus 4 is negative 3. So that seems to work. I will simplify these if I can. I can't simplify here, so I'm going to get 2x plus 1. Here, 2 goes into 2 once. It goes into negative 4 twice, so I'm going to get x minus 2. So what I can do here is I can solve for my intercepts. 2x plus 1 equals 0, so 2x equals negative 1. So x equals negative 1/2. And here, x is going to equal 2. So obviously my x-intercepts are going to be negative 1/2, 0, and 2, 0. So let me go ahead and set that up and see what we're talking about. All right, perfect. So that's what we expected, negative 1/2, 0, and 2, 0. We have our x-intercepts. But chapter 5 is trying to get us to see a couple things here. First of all, we want this point. We want to be able to get this y-intercept. We want to be able to get this axis of symmetry. You can see there's like an imaginary line that runs right down the middle that cuts this parabola in half. And you'll notice this point, the vertex, which we also want. This vertex is going to be on the axis of symmetry always. So we're going to use that to our advantage. Again, I can't draw on this one right here, but if I had a line right down the middle, you can see that it would look the same as on the right. It would be like a mirror right down the middle, cutting it in half. And our axis of symmetry would be right on the middle of that. So that is what we're going to do in steps 6, 7, and 8. So step number 6, what I'm going to do is I'm going to plug in 0 for the equation for x. And like I said, this I'm already doing more work than I need to, and I hope you see why. This is just going to be 0 squared times 0 is 0. Anything times 0 is 0 minus 4. I just get negative 4. Well, think about it. My x was 0. I told it to be I told my x to be 0, right? That's what I chose to plug in. And when I did, my y spits out a negative 4. So there's my y-intercept right here. And again, you can see pretty clearly that's pretty easy, right? That y-intercept should always be very easy to find. From there, how do I get this axis of symmetry? Well, there's 2 ways I can do it. You'll notice the halfway point, right? If this cuts it in half, I should be able to add these 2 together. So negative half plus 2 is 1.5, and if I divide 1.5 by 2, I get 0.75. So 0.75 should be my axis of symmetry. You see that it is. Or there's another way, which I think I like a little bit better. So again, if I just get the halfway point between negative half and 2, right? So I'm doing step number 7. I'm just sort of running out of room here, right? So negative half plus 2 is 1.5. Divided that by 2, I get 0.75. That would be my axis of symmetry. But there's another formula right here that I like a lot better. So for step 7, I'm just going to ask you to say negative b over 2a. So let's go back to the original question. What is my b? My b is negative 6. Well, what's a negative negative 6? A negative negative 6 is positive 6, right? And then what's 2 times a? 2 times 4 is 8. And hopefully we realize that equals 0.75. So you can average your x-intercepts if you want, but I'm going to use this formula negative b over 2a. So I know my axis of symmetry, again, is the halfway point between my x-intercepts, but I also know my vertexes on it, which means if I plug 0.75 into this equation, it will tell me where my vertex is. So again, what I'm going to do is I'm going to plug 0.75 into my equation for x and solve. I have to plug it in two places, right? I have x appearing two places, so I'll plug 0.75 in here and in here. Now I have to use order of operations, right? So I'll just grab this on my calculator. Actually, these calculators are kind of fancy. What I could do is I could just do the whole thing. I'm going to say 4 times 0.75 squared. Right? If I put the parentheses in here correctly, the calculator will be able to do all the math for me and make it a lot easier for me. Minus 4. So you can see I have the whole thing written down with the parentheses. Order of operations should be no problem. So it looks like my vertex is going to be at 0.75 and at negative 6.25. So let's see if these points are true. Let's go back over here. At 0.75, negative 6.25, I have my vertex. I have my x-intercepts. I have my y-intercepts. I know my axis of symmetry. Think about it. I could also put a point over here, right? If I'm at 0.75, if I go 1 3/4 this way, I get a point. If I go 1 3/4 this way, I get a point. And now I have a lot of points I need. I'm not always going to have Desmos, right? So I can actually begin to get a sketch of my parabola without needing a graphing calculator. Let me go and set up the next through example number 1 again. So there's nothing to factor. We make our diamond. We get x plus 4, x plus 2. We know our x-intercepts are at negative 4, negative 2. Again, I can get my y-intercept by just plugging 0 in up here. I know it's going to be 0, 8. I can get my axis of symmetry one of two ways. I can either get the halfway point between negative 4 and negative 2, which is obviously negative 3, or I can say negative b, which is 6, so negative 6 over 2a. 2 times 1 is 2, so negative 6 divided by 2 is negative 3. Either way, I get the same axis of symmetry. And then if I plug that axis of symmetry back into the equation, so I get negative 3 squared plus 6 times negative 3 plus 1. You can see again, I'll just do this on the calculator. I'm going to get negative 3 squared. By the way, on these calculators, this is the negative key, this is the minus key. I think it's stupid that it works that way, but you really have to make sure you pick the right one. So plus 6 times negative 3 plus 8. And you can see it spits out a negative 1. So my vertex, my x part of my vertex is negative 3. My y part of my vertex is negative 1. And now let's just go back over and see if that's true. Here we go. I have my y-intercept at 0, 8, like we expected to see. I have my x-intercepts at negative 2, negative 4, which we expected to see. And I have my vertex at negative 3, negative 1. So all of that ended up being true for that problem. I just wanted to kind of throw that out there. That way you can see how this works. I'll save example 2 for later, but you can see it's all the same stuff, right? We know we get 0, negative 10. I can use negative b over 2a, so negative 18 over 8 is going to be negative 2.25. And if I plug negative 2.25 into this equation, it's going to spit out negative 30.25. So I get these points of knowing what this looks like before I graph it. All right, let me go ahead and set up the next problem. See if we can graph this whole thing before we go to Desmos and then see what it looks like in Desmos. So first thing, there is no initial factoring. I can't take anything out of 1, 2, and 8. So I'll go to my diamond. A times c is negative 8. B is negative 2. I'll go ahead and put 1x there. I will, from there, see what I come up with. I get nothing out of 1 and 8. 2 and 4 works if the 4 is negative. Right? 2 times negative 4 is negative 8. 2 minus 4 is negative 2. I can't simplify these fractions, so I'm going to get x plus 2, x minus 4. Again, if I want to get my x-intercepts, I'm going to get x equals negative 2. That looks terrible. Oh, it all looks terrible, but that looks especially terrible. And here we're going to get x equals 4. So think about that. Ugh, that looks terrible as well. So let me try this a little bit better. So I have an x-intercept at -2, and I have an x-intercept at +4. That's how far I am so far. Now I'm going to go to step 6. I'm going to plug 0 in for my equation. You can see I get -8 out. So that's my y-intercept. Hopefully you're okay with me. Just like, it's obviously going to be 0 minus 0 minus 8. Now I need my axis of symmetry. And again, my preference is to use -b over 2a. If you want to get the halfway point between these, it wouldn't be hard. It's obviously 1, but when the problems get more difficult, I think it's easier to use this than it is this. For easy problems, this is easier. For more difficult problems, this is a -b, a -2 is 2, and then a 2 times 1 is obviously 2 divided by 2 is 1. So my axis of symmetry is going to be right here at x equals 1. And again, I know my vertex is going to be somewhere on here, but where is the question? What I'll do is I'll go back to this equation, and I will plug in 1 squared, minus 2 times 1, minus 8. So I get 1 minus 2 minus 8, I get -9. So there we go, 1 -9. So I have a parabola that looks, ugh, that didn't look good. Something like this. -2, 0 here, 4, 0 here, 0, -8 here, and 1, -9 here. I was able to graph this entire parabola. Again, think about it. If I had to go 1 here, what about 1 more here? Shouldn't I have a point at 2, -8 as well because of symmetry? So let's go ahead and look at what came up there. And you can see, there we go, -2, 0, 4, 0, 0, -8, 1, -9. We also have one right there, like I said, at 2, -8 somewhere. I can't get it exactly, but it's there at 2, -8. So there we go. We're able to graph a parabola now without Desmos. We can get enough important points. We can get the x-intercept, the y-intercept, and the vertex. And then this, I call it the symmetric point because we know that's there with symmetry. Again, we know that's that far away, that's that far away, right? There's that symmetry that comes through with that axis of symmetry. That is it for Chapter 5, Part 1, Day 1. Ugh.